Okay, pause the video, read the scenario, and then play it when it's time. So, to find the total deductions, let's call T the total deductions, and you could get deductions for X or Y. And how many points do they lose for non-word?
3.
They lose 3, so it's going to be 3 times the number, plus they lose 2 times the number of non-word deductions. So basically, we're trying to find the mean and standard deviation of this random variable, which is the combination of these two random variables. So to find the mean of T, we're going to do 3 times the mean of X plus 2 times the mean of Y, which would be 3 times 2.1 plus 2 times, is it just 1?
Yeah.
1.0. There we go. So the expected total deductions would be 8.3 points. 8.3. Cool?
Yeah.
To find the standard deviation. To find the standard deviation, I told you guys one way to do it, where we would say find the new random variable for point deduction for X and the new random variable point deduction for Y. I'm going to show you another way real quick. If we're finding the standard deviation of T, then it's going to be, I can't add standard deviations. I can only add variances together. So first I have to get their variances. So I'm going to do the variances combined. The variance of 3 times X is going to be the standard deviation of X times 3. Square it to get the variance. Then I add the standard deviation of the points for Y. Oops. And then I square it to get the variance. You with me on this?
Yeah.
We can only add variances, so I have to multiply, get the new variance, then square, or multiply to get the new standard deviation, then square it to get the variance. This will give me the variance of T, but I want to get the standard deviation of T. So all I have to do is take the square root of this, and that'll be my standard deviation. So let's plug in what we know. Sigma is 1.136. So maybe I'll just write this below actually. 3 times 1.136, and then I square it, add it to 2 times 1 squared. And so if you crunch that out, it'll give you 3.95. So the mean of the total points is 8.3. The standard deviation is 3.95. With me on that?
Yep.
Okay. Let's jump down to number 2. Number 2, video, pause it and read it. We're already ahead of you. And this one is the probability of a male being taller than a female. So we have to set up a new random variable. We're going to combine the male's heights and the female's heights. But what we're going to do is we're going to look at the difference. Difference between the male's heights and the female's heights. Why is this helpful for determining if a male is taller? If it's positive, the male's taller. If it's negative, the female's taller, right? So let's write down what we know about each variable. We know the mean of M. Somebody tell me what that is. I think it's 69.5, right? Standard deviation of the male's heights is 4, question mark? Yes?
Yes.
The mean of the female's heights is 64 inches, and the standard deviation is
65 inches.
5? I thought it was 3.
65. Yes.
Oh, it's 65. Okay. Thank you. And then this is just 3 inches, right? So what we're doing is we're going to combine these two to get the difference. We want to find the expected difference. So the expected difference is going to be the males 69.5 inches minus 65 inches. So on average, we expect the males to be 4.5 inches taller. You with me on that? Find the standard deviation. This is the reason I picked this problem, for the standard deviation part. Just because we're subtracting the variables, we're still increasing the amount of variation. So we never subtract variances. We always add. We always add variances. So the standard deviation, first we have to get the variances. So the variance of the male's height is going to be 4 squared. I always add variances. I never subtract. Plus 3 squared, because that is the female's variance. So let's go ahead and take the square root of this, which is 16 plus 9, 25, right? So the standard deviation of the difference is 5. So we expect their heights to have a difference of 4.5. It fluctuates typically by 5 inches. The important thing they tell us is that the heights of males and females are both normal. So what's the shape of the combined distribution going to be? It's going to be normal as well, okay? And it has a new mean here and a new standard deviation here. So let's sketch a picture of this. I'll put it right here. So the difference is normal, centered at 4.5, standard deviation of 5, and we want to find the probability that the difference is greater than 0. Because if the difference is greater than 0, that means the male is taller than the female. You with me on that? So use this and find the probability that it's greater than 0. That would be this shaded region here. How do I do this? Normal CDF from 0 to positive infinity. The mean is 4.5. Standard deviation is 5. Now we'll give you the answer. And it should be 0.8159, I believe. So 0.8159. So there's about an 82% chance that a male is taller than the female for speed date. Okay, last problem. I'll answer questions after I stop recording. Last problem, so we're picking how many apples? 12. And what do we know about apples so far? The mean is 9 ounces, so let's call X the weight of one randomly selected apple. So weight of one apple. We know it's normal, and we know the mean of X is 1.5 ounces. The standard deviation of X is, I got that backwards. The mean is 9. Standard deviation is 1.5 ounces. But how many apples are we picking? 12. So let's do T again for the total weight of all the apples. What would my equation be for picking 12 apples? It's x1 plus x2 plus x3 plus... It's not 12x. It's not 12x because 12x would be picking one apple that is 12 times the size. Okay, so this is, you're picking one apple, then you're picking another, and you're doing that until you get 12 apples. And this really only makes a difference when you're finding the standard deviation. Okay? So the expected value of T is going to be 9 plus 9, 12 times, right? We expect the bag of 12 apples to weigh 108 pounds, or ounces. So the expected value of T is 108. Then we have to find the standard deviation. So the standard deviation, I'll put a line here, of the total is going to be, we have to add variances, right? So the variance of 1 is 1.5, or I'm sorry, the standard deviation is 1.5. So we have to square it, 1.5 squared plus 1.5 squared, and we have to do that 12 times. And then if I want, this would give me the variance, but I want the standard deviation, so I'll take the square root of this. So if I add 1.5 squared 12 times, then it's going to give me 27. So the standard deviation is going to be the square root of 27, which is about 5.2. 5.2. So now I have a new distribution. What's the shape of t going to look like? Normal, because x is normal. Combine it 12 times, it'll still be normal. The mean is 108. The standard deviation is 5.2. What's the probability that the bag is less than 100 ounces? Draw a picture. Here's my distribution, centered at 108. 100 would be here. Shade the region. How am I going to find this in my calculator? Normal CDF. My lower bound is negative infinity. My upper bound is 100. And my mean is 108. My standard deviation is 5.2. Punch that in the calculator and you should get 0.062. So this should be the probability.